Hi everybody, in this video we're going to cover section 2.7, combining functions, and this will include composition of functions. So in this section we get to add, subtract, multiply, and divide functions. So here's a little bit of a graphic of what this means in terms of the domain. But we're going to do some examples. So anytime that you add, subtract, multiply, or divide functions, you do the intersection of their domains, and that is the new domain of the function. With the exception of when you divide functions, we still want to make sure that the denominator is not 0, which is why this is really important. Is A intersected with B, right? The domain of 1, the domain of F is A, and the domain of G is B. So when you intersect those domains, we want to make sure that the function g of x is not 0. For composition of functions, we take the input of one function and write the input of the x. If g takes it to g of x, and then we take g of x as the new domain and we put it into f, and that gives us f of g of x. And so we'll do some examples to illustrate all of these. So let's start with letting f of x, so let's call this example 1. Let f of x be 3 minus x squared and g of x be 5 minus x. And so looking at these, let's write down, always identify the domain of your function first. These are both polynomials, right? That's a quadratic, and g is a linear function, so the domain of f will be all real numbers. So minus infinity to infinity, and same thing for g. So the domain of g is also all real numbers. So minus infinity to infinity. So when you intersect those, you get the exact same thing. So let's try finding all the different combinations that we can have with functions. So let's start with f plus g of x. So this is the same, this is the notation, but this means f of x plus g of x. So in this case, taking our functions, f is 3 minus x squared plus g of x. G of x is 5 minus x. And now we combine like terms. So 3 plus 5 is 8 minus x squared. So this will be the new function. And notice that the domain of it is minus infinity to infinity. It's still a polynomial. All polynomials have domain of all real numbers. So let's try the subtraction. Say I want to find g minus f of x. So in this case, that means I'm actually doing g of x minus f of x. And so g of x is the 5 minus x function minus g of f of x. Now f of x has two terms, 3 minus x squared. So if you want to make sure that you don't forget to distribute that negative, then use parentheses. So 3 minus x squared. So this is my f of x. If you're pretty good about taking your negative through, just make sure that you distribute it, right? Don't just say minus 3 plus x squared. Make sure you distribute it. Or sorry, minus 3 minus x squared. So you distributing that, we get 5 minus x minus 3 plus x squared. And combining like terms again, so the only like terms are the constant terms. So 5 minus 3 is 2. So I get 2 minus x plus x squared. And this one you can write it in descending order. The x squared term is positive, so I can say x squared minus x plus 2. And again, notice that the domain is all real numbers. We still get a polynomial. So let's try what about f over g of x? So the division, the quotient. So this means f of x divided by g of x. And so f of x is 3 minus x squared, and g of x is 5 minus x. And so now notice that we don't get a polynomial. So I have to pay attention to the domain. The domain of this is going to be affected when the denominator is 0. So for the domain, we want to exclude all values where the denominator is 0, where 5 minus x is 0. So that means when x equals 5. So the domain is all real numbers except 5. So we say minus infinity to 5, not included, so parentheses, and then union 5 all the way to infinity, right? And not including the 5. And so that says all real numbers except x equals 5. So let's try now the composition of functions. So let's say f of g of x. So this is the composition of functions, and what this means, so the circle is the composition notation. And so what this means is that we're going to do f of g of x. So the g of x becomes the input of f. And so what this is going to look like then is f of x, remember f of x is 3 minus x squared, and g of x is 5 minus x. So when I put it in, right, g of x is my input, into f, this is going to look like 3 minus the input square. My input is g of x. So this means 3 minus, well, what is g of x? G of x is 5 minus x. And now we square that out because we want to simplify it. So this is 3 minus, and make sure you keep your parentheses. So 5 minus x squared means 5 minus x times 5 minus x. So don't forget to FOIL. Make sure you're not just saying 25 minus x squared, right? There are some middle terms here. This is 25 minus 5x minus another 5x and then plus x squared. So I get 25 minus 10x plus x squared. And now let's distribute this negative in. And so we end up with 3 minus 25 plus 10x minus x squared. So our final composition will be 3 minus 25 is negative 22 plus 10x minus x squared. And so that will be the composition. And notice that the domain, this is a polynomial, so the domain is all real numbers, so minus infinity to infinity. So a good one for you to try would be, what about g circle f of x? So the composition g of f of x. So go ahead and try that on your own and see what you come up with. So now this is the input. And remember, our g of x is 5 minus x. So that means that you're going to have 5 minus. So for every x, you're going to put in the input, f of x. And f of x is the 3 minus x squared. So I like to make use of parentheses so that I don't forget to distribute this negative. So I have 5 minus 3 plus x squared. So my final answer will be 2 plus x squared for the composition there. And again, what's the domain? Notice we end up with a polynomial, so the domain is all real numbers. In the next video, I'm going to do an example with functions that are slightly bit harder.